on the me side, so that's why you can say call me Dr. Said, because no other lecturer. Yes, someone have recorded this lecture. So actually, in the end of this lecture, you can see again the record in stream. Okay, you can find the stream. So stream also under Microsoft Team. You find the application stream, so you can see again our recorded lecture. Okay, so I think I can start because the number of student 155, I think about berapa belas lagi lah, I think dalam 20, tak sampai lah, dah 15 orang macam tu, tak masuk lagi. So I hope they can join us. If not, I think maybe they can watch our recorded video, because I cannot expect that all of you join this, because as I said, because of the connections. Okay, so for this mechanics, this is the topic that I cover. Okay, so I start with the linear motions, and then motion with the constant accelerations, and then free fall motion, and then projectile motion. So of course I know the syllabus in school also cover this type of outlines, but I think maybe it's not, it's just roughly just in the surface. So in this time in PASUM, we elaborate more about this, and then we introduce in new equations. And then some of equation you already exposed in SPN level, but in PASUM level or pre-university level, we just a little bit explain about this, and then we go much deeper, okay, compared to the school. Okay, and then if you look our lecture today, so as I mentioned in Microsoft Team, I already uploaded my lecture note in Spectrum. So if you go to the Spectrum, now it's good Spectrum because they put the picture of the lecturer there. So you find my picture, and then you click that, and then you can see that they have a lecture note, the folder of lecture notes. And then it also have a after, I think, end of this day, I will upload the tutorial. Okay, the tutorial in other material. So you can find another folder. Number one is lecture notes. Okay, so I uploaded 2 lecture notes, lecture note number 1 and also my lecture note number 2. Because of my 3rd lecture note, I will upload tomorrow, because we have the sum of class. Because if you look to this week, the timetable is not equal or same with the next week, because of this is because tomorrow is a holiday. So that's why they need to arrange the timetable. Okay, so for these linear motions, okay, so after or in the end of the lecture, the students must be able to define displacement and distance. So they have the difference between displacements and distance, and then define the velocity. So they have the 2 types of velocity, the average velocity and also instantaneous velocity, and then define accelerations. Okay, so again, they have the average acceleration and also instantaneous acceleration. So for today is not technical, just a lot of informations and the knowledge about we call it as notes. Okay, so just introductions without calculations. Okay, just information. So that's why I hope that you can concentrate. Okay, now we start with this. Okay, because this is a Muslim Olympic, so can you see this animation first? Because I want to relate with the linear motions. But it's not this current Olympic. It's not in Japan. I think this is in Rio in 2016. Okay, this is 100-meter sprint competitions. And then if you notice, there is Usain Bolt. If you notice lah. Okay. Okay, that's the linear motion. So the question is, please mute your, yeah. Okay, please mute your mic because I don't want any interaction. Okay, thank you. Okay, so my question is, what are the parameters involved to describe linear motions? Okay, so in physics, so they have the parameter of physics. So what I mean here is the parameter of physics that involve the linear motions. Okay, if we look at the linear motions, okay, for example, these animations. So what are the parameters involved to describe the linear motions? Okay, number one is, okay, if you look, this is a 100-meter. Okay, 100 meters. So the number one is the displacement. Okay, for the linear motion, it must have the distance or displacement. So that's why this is we want to discuss what is different between distance and displacement, because of in the this some angle we can find that this is maybe equal. Okay, displacement is equal to distance, but at the angle we can see that they have a difference between the distance and also the displacement. So this is one parameter that involved in the linear motion that we will discuss about the linear motions. Number two is the time. Okay, when it move, so you look to the Usain Bolt. So when in 100 meter, he can run about 9.5 or 9.64 okay seconds. So they have a time there. Okay, number one displacements, and number two is time, and number three, so it also involved with the velocity. So when the sprinter ran or run, okay, so they have the chain of displacements. Okay, when you move from here for another one spot to another spot, they have the displacement, and also have the distance, and then in time. Okay, berapa lama masa yang digunakan. So that's why from that we have the velocity, and then because as you know velocity, the unit is meter per seconds. Okay, we have meter per seconds, meter in seconds. So that's why it involve the displacements and it involve the time. Okay, and then last is the accelerations. Okay, so acceleration is the chain of velocity. Okay, because if you look to the unit of acceleration is meter per second square. Okay, meter per second square. That's why you have the velocity is meter per seconds, and then you have another seconds. That means the chain of velocity over time. So this is the four parameters that we discussed to describe the linear motions. It's not just for today, okay, because it also relates with our second lecture. Okay, after this we will discuss about the free fall motions, and then we discuss about the projectile motions. So it's also involve all of these parameters that I introduced in the first slide. Okay, I hope you can get that. And then now we look to the displacement. Okay, as I mentioned, in the some angle we can see that displacement is a distance. Okay, but if we look to the real definition of displacement is defined as the change in the position of the point and is a vector quantity. Okay, I hope you know the vector quantity. So if we look to the displacement, it must have the chain of positions from A to B, B to C, C to D. So they have the chain of position. And then because it's vector quantity, it must have the directions, because as you know, vector must have a magnitude and direction. So that's why the directions here to there, or you can forwards. Forward is direction ke depan, and backward ke belakang. So that's why it's positive X, is negative X. So that's why they have the distance. Okay, this distance is the chain of positions and must have directions, either positive X or negative X. So we talk about the X lah, it's not the Y, because Y is a vertical. So we talk about horizontal because it move in the horizontal plane. Okay, so if you can see the picture, the change of the placement is delta S. Delta S is the placement is S final minus S initial. Okay, S final minus S initial. So that's why final spots you minus the current spot or initial spot. So that's why you have the delta S. So if we can describe this with the distance, okay, because after this we want to have the difference between the distance and the displacement. So now what about the distance? Okay, the displacement is moved from one spot to another spot, and then S final minus S initial, and then define distance defined is the length. Okay, it's the length. It's not the chain of the spot. It's the length. Okay, I hope you can get the difference. Okay, so distance is defined as the length. Distance is defined as length of actual path have moved, and it's the scalar quantity. Okay, scalar quantity, as you know, is not have the directions. You can go this way, that way, no matter, because it's distance. Okay, it's the length. So that's why, therefore, the total distance S1 plus S2. You just plus S1, just plus S2. Okay, so that is the distance. And then if you look to the placement, is the move from the one spot to another spot. Okay, boleh? Now we look some example. Okay, here. Okay, if we look at the what I call it spider. Okay, spider move from the 10 cm here. Okay, if you look at the 10 cm to 60. Okay, 10 cm to 60 cm. So that's why this is the punya S final 60, and then this is S initial 10. So that's why 60 minus 10, you have the positive 50 cm. So when you have the positive 50, it's actually a displacement. Okay, it's displacement. What about the distance? So in this case, the distance also same. Okay, 10 to 60, the distance is also 50 cm, but it's not, we will not write as a positive because as I mentioned, distance we don't have the direction, so it's just 50 cm, but the displacement is positive 50 cm. Okay, if you look at another case, is the spider is from 60 cm and then is reverse. Okay, it's reverse or turn back to the initial 10 cm. So that's why we have the delta S or delta X, the placement is negative 50 cm. Okay, because this is the placement is negative 50 cm. But if you look to the distance, okay, distance is the same with this 50 cm. Okay, displacements positive 50 cm and also negative 50 cm, but the distance is 50 cm. This is 50 cm. Okay, what about the total distance from A to C? Now A to B, B to C. Okay, what about the total distance or the total displacements? Okay, so if we look to the total, for example, in this, okay, so this information, okay, I'm transferred to the graph. Okay, graph is S over T. So you have S is for the displacements, okay, from 10 cm to 60 cm. So again, the same with this picture lah, okay. And then it's moved to the 10 to 60, positive 50 cm, and then it's turned back or reverse from 60 cm to 10 cm. So that's why we have a negative 50 cm. So if we look from this graph, okay, we can have the total distance A, B, C, A to B to C. So if it's distant, because it's just a length, okay, this is the length. So we count that 50 cm plus another 50 cm. It's not involved positive or negative, as I mentioned, because it's distance. Okay, it's without the direction. So just 50 cm plus 50 cm. So we got 100 cm. Okay, but what about the total displacement? Okay, the total displacement, if you look, it start from the 10 cm and then is end also to the 10 cm. Okay, and okay, thank you. Some of you already mentioned in the chat. Of course, it's supposed to have a 0 cm. Okay, it's quite simple, but you need to know the situations. Okay, so even though from this point to another point, so if you look to the map of Pasum, I'm not sure if you remember or not. So from Pasum, actually they have the two ways that you can move. Okay, number one, from the Pasum through the college Kelima or API, if you're familiar lah with the UM, and then you can pusing, and then you can sampai dekat Pasum juga. Another way is you just turn left. Okay, daripada Pasum, you can turn left with the engineering faculty, and then you have Perdana Siswa, and then you have the Dewan Kuliah Utama, and then you can reach the Pasum. So even though you walk for the 5 kilometer or 6 kilometer, and then from the same spot, okay, from Pasum, and then you walk 5 kilometer, and then again to Pasum. Okay, so the same spot, initial and the final in the same spot. So that's why we call the placement as the 0, but the distance we call as the 5 kilometer, because you walk 5 kilometer from Pasum to Pasum. Okay, you walk from Pasum 5 kilometer to Pasum, so the placement we count as a 0, but the distance we count as the 5 kilometer. Okay, boleh ya? I think it's quite simple, but to make you more understand about this, so we try a game. Okay, I think you need to think. Okay, pagi-pagi ni kan. So I call this the mind challenge. So I will put this we'll call that this address in the chat box. Okay, wait. we try this challenge, or maybe you can write. So before if I paste, I copy this address. Okay, a little bit slow. Okay, wait. Okay. Okay. Okay, please look on the check box. Yeah, thank you. Someone already helped me to paste that. Okay, so you try that again first. Okay, so if you enter to the games, okay, I post another the same thing. Okay, you will see this. Okay, distance and displacement challenge. Okay, I give you about 5 minutes. Okay, so the rule is there. So you were given the distance and the placements. Okay, for example, in my slide, 2 meter distance and negative 0.7 meter displacements, and then the rule is you need to move just once, either to the right side or to the left side. Okay, if you look to this ball, they have the indication of the red dot here. So after you move to the point that you want, you must pause. For example, to the left, I want this negative 0.5. I move to the left, and then when I reach negative 0.5, I pause, and then I want to move to the right, and then I click play again, and then I pause. Okay, so the system will give you the information, either you're correct or either you're wrong. Okay, please try. So if some of you success to get this, please raise your hand, so I will know the situation that you can get the right answer or not. Okay, as I mentioned, you use the information that I've given before. What mean by distance, what mean by displacement. So you can ask if you have any problems. If you need to run again, you just click refresh. Okay, if you run and then it's wrong, you need to run again, you click refresh. So if you have an other questions, it will not return to the same question, so it will move to other questions because you just have one time attempts. Okay, if you success to get the right answer, please raise your hand so I will know. Okay, take your time, think about the knowledge that you have learned before. Okay, for those that just join us, so please check in our chat box. So they have the link or address there for the mind challenge. Okay, yes, Kamal Faiz, the first one that can get the right answer. Congratulations. So we wait for 173 more students. Okay. Okay, anyone? Just one. It's okay. Just try again, try again. Okay, just refresh and try again. Okay, if you correct, you will have these appearances. Okay, you stated good word, enter your name. Okay, you can enter your name, you can submit, and then it will give the completion certificates. Because of in physics must have a plus minus, so it's not just must meet the distance or the placement. So just have a plus minus. So it's close is considered correct. Okay, so you do okay until you get this certificates. Okay, Aina Nur Mus. Okay, Muhammad Adin, Aina, good words. Okay, just three. Okay, so far I have four students that completed this challenge. Kamal, Faris, Aina, Adin, and also Iya, Shauki. 5. Okay. You still have a time. This is to enhance your knowledge about the distance and also the displacements. Okay. We have Adam, we have Bakhtia, we have Alif, we have Salahuddin. Okay, good. I think about the 12 students. If I say the percentage is quite low lah, because it's 12 or 10 out of 177. This is just 0.0%. Okay, we still have a time. Please try. Okay, it's 14. The number of students is increasing. Okay, 15. At least I can get 50. Okay, at least I can get 50 students. The correct answer, so we can forward. Or we can move to our next. So I need a 50. I need a 50. About 1/3. We have the 170, so at least we have 1/3. Okay, now 18, 20 is good. Keep going. Okay, 26. Okay, I need 24 more. Don't cheat, eh? Okay. Okay, 27. Okay, 9. 30. Okay. We have 177 students. Okay, please try. Come on. Come on. Okay, I think we can proceed because I afraid that we reach to the 9 o'clock. Okay, because I also have another lecture in 9 o'clock. Okay, so if you look to this challenge or to this game, so you need to move either right side or the left side. So for example, in my case, okay, if you look at my case, so the distance is 2 meter, and then the placement is negative 0.7. Okay, and then if you look to the information or the knowledge that we learned before. Okay, so if we look first is the displacement is the s final minus s initial. Okay, that's why you have the delta s. Okay, delta is actually a displacement. Okay, it's not the distance. Displacement is negative 0.7. So that's why initial is this is in my case, so you can relate with your case. Okay, so for example, in my case, initial is 1 meter. Okay, that's why you have the sy is 1 meter, and then as final, so because this is a negative, that delta s is negative 0.7, so that's why I can have the as final. Okay, so as initial is 1 have been given, okay, from that challenge, and then delta s have been given because of negative 0.7 meter is a delta s, because it's the placement. So that's why you have a delta s is negative 0.7, and then you have S1 is 1 meter, so you can have the S final. So that's why in my case, S final is 0.3. Okay, 0.3. So this is the displacement. Okay, so that's why when we have the 0.3 minus 1, that's why you have negative 0.7. That the distance, because S final minus S initial. But the distance you can move forward or backwards. Okay, no matter forward or backward is a count as a distance. So in this case, I move to the left 1.36. Okay, so because of the right is 0.65. Okay, and then because when I sum of that 1.36, sorry, 1.35 plus 0.65, I have the 2 meter. Okay, so I think you can try that. Okay, so before uh, we move to another chapter, I give you another 5 minutes break. So that's why for those that still do not get the right answer, you can try. So for those that already get the right answer, so you can have a breaks if you want to drinks, if you want to go to the restroom or anything. Okay, we have break about 5 minutes. Okay, stay tuned. I will meet you again in another 5 minutes. Thank you. Okay, some of you uh, already messaged me because of, I think, because of connections. Okay, because we just left for 5 minutes and then our connection is run, so that's why it's less. Okay, so I think we can continue, because of it's auto. Okay, I agree, because of if you look just left for the 5 minutes and then your internet connection is run, so that's why we will lose our internet connections. Okay, do you agree? So for those that raise your hand, please raise down your hand first, because I'm not sure if you have any questions. I think before this, I need you to raise your hand. So I think you can. Okay, thank you. Okay, so now we already discussed about the displacement and also the distance. But in this case, so we just need to memorize the displacement, because for other, for example, this velocity, we use the displacements. Okay, now we look to the velocity. Okay, velocity. Every number one is the average velocity, as I mentioned in the beginning. So we have the average velocity, and then you have the instantaneous velocity. Okay, what I mean by average velocity? Okay, average velocity is defined as the chain of the displacements. Okay, remember the chain of displacement divided by the total time taken for this displacement is delta S. Okay, it's delta S. Okay, divide by delta T. First spot to the final spot. So you have the first initial velocity, final velocity. You have an initial time, is final time. So that's why you have a delta S and also the delta T. This is for average velocity. And then you also will find average speed. Okay, when it's related with the speed, okay, it's related with the distance. Okay, I think you already get the point, the difference between the displacement and also distance. I think will be much easier for you to understand. Okay, speed, distance, velocity, displacement. That's why speed do not have the directions. Okay, speed do not have the directions. Velocity we have the direction because it's a vector, and then this is a scalar. Okay, average velocity, total displacement over total time. And then we have, for example, here, okay, again the same spider, okay, from 10 to 6 in 5 seconds. Okay, so that's why you have the average velocity is positive 10 meter per second. Okay? And then you have B to C, it's reverse. Okay, initial is 60. So that's why you have negative 50. The displacement and also the total time is 5 seconds. So that's why you have a negative 10 centimeter per second. Okay, and then when we transform this to the graph, okay, we have the graph then to 60 in 5 seconds. This is another 5 seconds. Okay, so that's why we have a 10 cm per centimeter, and then you have a negative 10 cm per centimeter. Okay, and then if we look from this, we'll have the average velocity. Okay, A to B is 10 cm, and then average velocity B to C is negative 10 cm, and then we have average velocity A to B to C is
Total
0 centimeter per second. Okay, because of we have the
total
displacement also 0. Okay, because of 10 initial
total side.
and the final you have 10. So that's why delta S you have a 0. So that's why you have delta S0 take 0. Okay, the total of time. Okay. So now look to the instantaneous as total displacement with the instantaneous just involve the Hello, I think, can you hear me? Yes.
Yes.
Yes, yes.
This is the thing that we're afraid to. Okay, because of the connection, as I mentioned, because of the connections. Okay. So I think I can continue. Okay, wait there. Okay, this is really the break. Okay. Wait there. Okay, good. Can you hear me? Hello.
Yes.
Yes. Ah, can you hear me right now? Dengar tak?
Yeah.
Okay. Okay, thank you. Sorry. Because as I mentioned that we're afraid. Okay, because I think I just have about a five slide. I think we can fit on my slide because they disappear. silence, we cannot have a break. Okay, we must to finish as much as we can. Okay, start again with this Microsoft Team. Can you see my slide? Do you see my slide?
No.
No, sir.
No.
No, sir.
Sorry, dengar tak?
Dengar.
Dengar.
I think I need to left and then okay. I think I need to left first and then I will come again. Okay, I think we could finish this lecture with okay, benda macam ni yang kita, because this is not online as I mentioned, because it's online, so we were exposed to this situation. Okay, boleh nampak slide tak sekarang?
Boleh.
Okay, thank you. I think we can. Okay, thank you. I think we can proceed. Okay, so from this is instantaneous as I mentioned. Okay, if we look to this graph, okay, we have the spot A, B to C. This is means by instantaneous velocity. Okay, if we look to the average, is from the beginning to the end. This is the average. So for the instantaneous is A, B, and C. That spot only. That's what we call instantaneous. For example, at A, okay, so the instantaneous velocity is 10 cm. And then if we look to B, okay, to B, I think you know this instantaneous velocity is 0. Okay, because of its unchanged of the placements. It's kita panggil velocity mala. Okay, it's constant velocity. Okay, that's why. And then C instantaneous is -10. Okay, again because instantaneous is only that spot. Okay, in any seconds. And then if we look, the average velocity is equal to the instantaneous velocity at the constant velocity. Okay, if you look A to B, they have a gradients. Okay, if you look at gradients, okay, A to B they have a gradient. So any point in that gradients is equal. So that's why average velocity is equals to instantaneous velocity at the constant velocity. A to B is the constant velocity, B to C is the constant displacement. Okay, B to C is the constant displacement. So that's why we have A to B is 10 cm, average, okay, and then instantaneous also is 10 cm, because as I mentioned, any point on that gradients is will be equal. Okay, and then again, average velocity C to D is a -10 cm, and then instantaneous velocity is -10 cm. Okay, that's it. And then we have the difference between instantaneous and also average as I mentioned. Okay, saya dah beritahu tadi, instantaneous only involved at a certain time, velocity or average involve the total time. Okay, And then instantaneous involve at the instant time close to 0, involve the overall of time. And then instantaneous is the single instant in time, and then the average velocity doesn't exactly show how fast an object moving at a certain distance. So if because we call as average, so somehow in that journey, so you can stop, you can increase the velocity, you can decrease the velocity. So this is called instantaneous. But overall, we just count as overall. So that's why the overall velocity cannot exactly show how fast an object moving in a certain distance. Okay, and then we have the average acceleration, the same thing. So that's why I can speed it up, because I think it's the same thing. Average acceleration is the same with the velocity. Okay, because of it's involved the velocity change. So when it relate to the velocity change, it's related with the displacements. So now we not discuss about the distance. Okay, we discuss about the velocity with the displacement, and then displacement involved with the average. So for the average solution, it's the same as total V. Okay, total velocity, average velocity times by total of time. And then we have, for example, this average accelerations A to B. Okay, this is V over T. Okay, V over T. And then we have the 10 cm for average accelerations, and then we have the average acceleration for B to C is 0, because this is a constant velocity B to C. And then we have the average acceleration A to C is 5. This is initial, this is final. Okay, and then time is 10 seconds. So that's why we have the delta V is 50 cm. Okay, is 60 minus 10, we have the 50 cm, and then you divide by 10 because of A to C. So that's why you have the acceleration average A to C is 5 cm. Okay, and then as average acceleration A to B, okay, is 10 cm. Okay, I think is straightforward. And then again, instantaneous acceleration, the same thing with the instantaneous velocity, because it's just involved at a certain time. For example, this, okay, so if we look to this graph, the same graph, so you look average accelerations A to C. Okay, A to C here is 5 centimeter per second square, as we discussed before. And then what about the X? Okay, you know that X at the A to B, so that's why you have X is 10 cm. I think I lost my slide. Can you see my slide or no?
No.
No.
Okay, I
No.
think, yeah, I think we just 2 slides to finish. Okay, I try to upload again. I think this is the first time. So as expected, okay, as expected, so we will face this connection problem. Okay, I just take 1 minute because it's already 9 o'clock, because you have a 9:10, okay, for another lecture, so you have about 7 to 5 minutes rest. Okay, so here, okay, x y is 0, okay, because of instantaneous acceleration is same with the instantaneous velocity. So either x or either b, so either x or either y is involved with the v over t graph. Okay, average acceleration A to C is 5 cm, and then instantaneous acceleration at x is 10 cm, and instantaneous acceleration at y is 0. Okay, good. Thank God. This is the summary. Okay, you need to know the displacements, velocity, and accelerations. Velocity, we have the average, you have instantaneous. Acceleration, we have the average, you have the instantaneous. Okay, I have simple questions. I'm not sure is simple. Okay, sempat tak you all nak buat, because I think simple kita buat sama-sama lah. Okay, number 1 is the rate of change of displacements. Simple lah ni. Okay, apa dia?
Velocity.
Yeah, good. Thank you. And number 2, if the body after traveling some distance come back to its starting point. Okay, jadi pergi dan patah balik. So it's about average speed is, or average velocity is because it's about the distance come back. It's average velocity is 0 or speed velocity is 0. Okay, A number 1. Yes, thank you. Good. And the last question, during uniform motion of an object along a straight line, it remain constant time. This is velocity. Okay. Boleh? Number 1 tadi is 2, and then number 2 is the average basic 0. Number 2 is 1, and number 3 is the velocity. Thank God. Okay, thank you very much. So I think you need to prepare to another class. So we meet again. I want to thank you for attending this class, and I'm very sorry because of the connection problems. Thank you. So we meet you again to our next lecture. Thank you. Bye bye. Assalamualaikum.
Waalaikumsalam. Thank you, sir.
Thank you.
Okay,
Thank you, Doctor.